This is Light at Speed, and in this video I will be discussing Bluetooth Low Energy lighting control. Welcome to another edition of Light at Speed with remote controlled lighting and precision lighting. In some of my previous videos I've looked at the lighting control protocols 0 to 10 volt, DALI and DMX. These are specific data protocols or dimming standards which many manufacturers can adopt or design to work with. However, there's another group of control systems which has gained incredible popularity in the last few years, and one that I use and my family do at home. Bluetooth Low Energy. It's often shortened to BLE, but Bluetooth Low Energy is a secure low-power, meshing-capable radio transmission system, which is already built into all modern mobile smartphones and supported natively by the vast majority of computer operating systems. But Bluetooth Low Energy is only the signal carrying standard, and therefore is more like the cables on which dimming signals are sent. Simply saying Bluetooth does not necessarily indicate what data is being sent or received via it. For example, at home, I use Casambi, which is a specific company's system for controlling lights using Bluetooth Low Energy as the carrier. There are many other excellent companies like Zacato, which use Bluetooth Low Energy to control luminaires, but for the time being at least, they can't operate with each other's devices or software. You may question why, and I'll get onto that in a few minutes. Bluetooth Classic has its root back as far as 1989 and was first used in a consumer device in 1999, but Bluetooth Low Energy, or BLE, was released as part of Bluetooth 4 in 2009. It would take a few more years for lighting to join the party, and a number of companies started developing their own systems to use BLE as the wireless carrier for their methods. BLE operates in the 2.4 GHz spectrum, which is similar to classic Bluetooth, Zigbee, Thread and Wi-Fi, but uses a strong frequency hopping strategy to avoid interference. In BLE lighting systems, the basic premise is the same. Luminaires are controlled wirelessly by Bluetooth Low Energy enabled input devices like mobile phones, tablets, but also by physical switches and sensors. BLE devices can be configured so that every device meshes and repeats the signal with every other device that it can. This is very cool because in theory you only need to be able to communicate with one device, and that device will send its signal on via every other device if it needs to. It also means that if any one device fails, it will not affect the system as the transmission route is a repeated mesh. However, not all BLE systems work this way, because if all the devices are sending and receiving data, there's a potential for data congestion. So some companies decide to select a certain number of devices to be repeater nodes. These are normally selected due to their position within a space to provide the best signal strength with the least chance of congestion. Some systems can automatically adjust which devices are repeaters to best service that network. Bluetooth Low Energy lighting devices come in many types. There are remote modules which can receive BLE signals and control, for example, 0 to 10 or DALI drivers. These are already widely used as they can convert any existing luminaire to work on a Bluetooth system. There are BLE-enabled LED modules, like this one from Zacato, which operates on Zacato's BLE system, or Bluetooth-enabled lamps like this one from Karus, which works on Casambi's system. Luminaire manufacturers can embed the chips and antenna needed for BLE directly into the luminaires or into the track adapters, giving very sleek products which look just like traditional non-BLE fittings. There, of course, also exist BLE-enabled switches like these from Casambi and Inocean, which enable you to turn the luminaires on or dim them or recall scenes, but there are not lots of options for those built switches yet, which is why companies have created switch converter modules which lets you take an off-the-shelf switch and convert it to a Bluetooth one. This could be a simple existing or historic toggle switch which gets a new lease of life. Then you have the sensors. These can be light sensors which could change the lighting level depending on the ambient light level, or PIR presence detectors which turn lights on if a motion is detected, all wirelessly. However, most of the population have a Bluetooth phone in their pocket, and BLE devices can detect those phones. This locational awareness can be used to turn luminaires on or trigger scenes without a dedicated sensor. Bluetooth Low Energy devices are said to have a stable range from each other of 50 meters, but in the real world, there are factors which can reduce that. If the BLE devices are located inside luminaires, the body of the fixture could easily interfere with the signal and reduce the range. If there are physical barriers like walls between devices, there will be a reduction in the range, and the thicker and the denser that barrier, the greater the drop in the range. But even in projects made of solid stone or metal, with clever planning, most Bluetooth installations can be robust, and if needed, even standalone Bluetooth signal repeaters exist, and they can fill the gaps. Integration of Bluetooth Low Energy with other control systems is also something worth considering. Maybe you've got a new build project with a DALI control system and installing of cables is easy, but there are a few luminaires which need to be wirelessly controlled. There exist modules which can be plugged into the DALI bus like another DALI device and trigger those lights to do what they need to do wirelessly, but initially by that DALI signal. Then you have the gateways. These devices can communicate with other lighting control systems over a building's computer network, meaning an overall lighting system could cooperate with a Bluetooth system. These gateways are connected to the network, which mostly means they're connected to the internet. This is so cool because it enables remote access to that system, really useful for setup and modification even from a completely remote location, all over the internet. Technically, BLE systems do not need to use standardized dimming curves, but many choose to use the DALI dimming curves. If other dimming curves are needed, these can usually be customized quite easily too. The maximum number of devices that can exist on a BLE network is technically tens of thousands, but depending on how the system is used, this can be as few as a couple of hundred. It all depends on the amount of data being sent and whether all the devices talk to each other in a complete mesh, or if only some of them act as repeaters. In systems which have lower maximum numbers though, multiple networks can be connected together using that gateway. Interoperability between Bluetooth systems is coming, but it's not quite there yet. Firstly, it's worth mentioning that the development of these systems is not easy or cheap, and when many of these developments were started, there was not a standard BLE lighting language to abide to. So companies developed their own languages, software and hardware independently, although they're all using BLE. There does exist the Bluetooth Special Interest Group, or SIG, who is in charge of developing Bluetooth in cooperation with industry partners. The Bluetooth SIG have written the BLE mesh standard, which, if adopted, enables interoperation between these devices. A number of lighting equipment manufacturers have developed components which are SIG qualified, which is fantastic. But currently, there are not enough key players who can offer this. In conclusion then, there are many Bluetooth Low Energy systems out there, and until all adopt the SIG mesh standard, having more than one company system work together will be tricky. But it's coming. Dimming curves are non-standardized, but most use the DALI dimming curve standard. Different BLE systems work better for different projects. Some are self-commissionable, easy to use, but still offer great customization. Other systems will always require commissioning, which does cost money, but by having a system commissioned, you could end up with a purpose-built system ideally suited to the project. Different systems have different numbers of maximum devices per network, but networks can be linked together using gateways. Purpose-built BLE input switches are not widely available, but using interface modules, it's possible to convert almost any switch type into a Bluetooth Low Energy system one. Being wireless, you don't need to run signal cables. This could well mean that there's a cost saving of installation and in the cabling. No wires is also very useful when you have an existing project, but they can't add cables. Although, being wireless, you need to have careful thought when designing a space to make sure that the signal will reach everywhere it needs to. I would suggest it's worth speaking to the company's teams when designing a system, as many of these companies can help you pick the right parts for that project. Thank you so much for watching. Be sure as always to like, share and subscribe, and I look forward to seeing you again soon. By the way, that was one take.